Hello, this is Dr. Luke's. Chapter 18 is over multi-loop and multivariable control, and we're going to begin looking at that in this video. So far we've been looking at single input, single output systems and the control loops that go with that. If you look in this first diagram over here, you're going to see something where we have just one input and one output. So SISO, single input, single output. And we might have lots of different disturbances. That really doesn't matter, but it's the input and output that we're looking at. So what we want to start looking at now is the more complex systems that have multiple inputs and multiple outputs. You're going to have one or more variables that are being controlled. So in the middle drawing, there are two inputs, okay, and two variables that are the outputs that are what we will be manipulating. And then I also could have more than that, right? 2 by 2 is not my limit. And I don't have to have the same number of inputs and number of outputs. So lots of ways we can have a multiple input, multiple output problem. Okay? And most of our control systems have this strong tendency to be MIMO problems. Okay? You're looking, for instance, at your product quality and the product quantity. That's two different things that you're trying to manipulate, or control, rather. We can think of a generic balance, okay? If I have two inputs and two outputs, and both of them relate to each of the others, then I have sort of a generic transient balance that would be that Y1 is going to be a transfer function times U1 and a different transfer function times U2. Add those two together. And similarly, Y2 is going to relate to U1 and U2 through those transfer functions. So I'm designating them as G sub P for the process. First subscript is for the output variable, second subscript is for the input variable. And that's fine. I can look at this in a matrix notation that Y1 of S, Y2 of S, okay, that I might call Y, is going to be GP11, GP21, GP12, left the P out, okay, there we go, and GP22. Each of those being a function of S, those transfer functions. And they are multiplied by my inputs U1 of S, U2 of S, the manipulated variable. Okay? And we can write this in a shorthand notation that Y of S, and this is a column matrix, so it gets one underline, it has one dimension. And this is equal to GP, which is two-dimensional, times U, which is one-dimensional. Okay? So we have this. And of course, if you want to account for disturbances, I might write Y of S is equal to GP of S, U of S, plus G for the disturbances times the disturbance vector. Okay? So this is a notation that we can use. This notation is helpful to us because it's a compact way of writing a lot of information, right? This does not need to be 2 inputs, 2 outputs. It could be 15 inputs and 15 outputs that are all interrelated. But it is a way of writing it so it isn't terrifying to look at. So I'm going to wrap up this video. In the next video, we're going to develop one of these for a specific process, and then we'll begin looking at how we can control these. Thank you very much for your time.